Hello everyone, and welcome back to my channel, Code with AHMAD. Today, I'll show you how to make a smart Bluetooth-controlled fan using Arduino. This fan can be turned on and off just by sending voice commands or text messages from your smartphone. You can also adjust the fan speed and even see the RPM value of the motor in real time. This is a perfect beginner-friendly project that uses some of the most powerful features of Arduino: PWM speed control, interrupts, and Bluetooth serial communication. Before we start, make sure you subscribe to my channel if you enjoy Arduino and programming projects. Alright, let's begin with what we need for this project. The code is in description. Section 1. Components. Overview. Now let's take a look at all the components required for our smart fan project. You'll need an Arduino Uno or Arduino Nano board, an HC05 Bluetooth module for wireless control, a 12-volt DC fan, the kind we usually find in computers, a 1 kilo ohm resistor for the transistor's base, and finally, some jumper wires, a breadboard. That's all you need. Nothing too complicated, just basic and affordable components. Now let's start connecting everything step by step. First, take the fan's blue wire and connect it to digital pin 9 on Arduino. This pin is a PWM output pin, which means we can use it to control the fan speed smoothly. Next, connect the fan's green wire to pin 2. This is our tachometer input. The Arduino will count the number of pulses from this pin to calculate the fan's RPM. The yellow wire from the fan goes directly to the Arduino 5-volt. The black wire connects to Arduino ground. Section 3. Connecting Bluetooth module. Next, let's connect the Bluetooth module. Connect VCC of the HC05 to 5 volts on Arduino. Connect GND to Arduino ground. The TX pin of the module goes to pin 10 on Arduino, and the RX pin connects directly to pin 11. Normally, people use a voltage divider for the RX pin to reduce the voltage, but in my setup, I'm directly connecting it to 5 volts, and it works perfectly fine. Just make sure your connections are tight and your module doesn't heat up. That's it. Once these connections are complete, your circuit is ready to go. Double-check all the wiring before powering up. Congratulations, your smart fan hardware setup is complete. Now, let's move on to the coding part and see how we can control this fan through commands from our mobile.
طلع البدر علينا من ثنيات الوداع وجب الشكر علينا ما دعا لله دا ما دعا لله دا طلع البدر علينا من ثنيات الوداع وجب الشكر علينا ما دعا لله دا ما دعا لله دا. Oh, the white moon rose over us from the valley of Wada, and we owe it to show thankfulness where the call is to Allah. أيها المبعوث فينا جئت بالأمر المطاع جئت شرفت المدينة مرحبا يا خير ذا طلع البدر على best amongst us, coming with the words to be obeyed. You have brought this city nobleness. Welcome, oh caller, to God's way. طلع البدر علينا من ثنيات الوداع، وجب الشكر علينا ما دعا لله داع، ما دعا لله داع. طلع البدر علينا من ثنيات الوداع، وجب الشكر علينا ما دعا لله داع، ما دعا لله داع. طلع البدر علينا من ثنيات الوداع، وجب الشكر علينا ما دعا لله داع، ما دعا لله داع. طلع البدر علينا من ثنيات الوداع، وجب الشكر علينا ما دعا لله داع، ما دعا لله داع. Oh, the white moon rose over us from the valley of Wada, and we owe it to show thankfulness where the call is to Allah. أيها المبعوث فينا، جئت بالأمر المطاع، جئت شرفت.
First, we include the software serial library. This library allows the Arduino to create an extra serial port for Bluetooth communication, since the Arduino Uno only has one built-in serial port. We define our pins here. Pin 9 controls the fan speed using PWM. Pin 2 reads the fan's tachometer signal to measure speed, and pins 10 and 11 are connected to the HC05 Bluetooth module. Now let's move to the void setup section. This is where everything starts when the Arduino powers on. We first set up the pin modes. The fan control pin, PWM, is set as an output. The tachometer pin is set as input pull-up. Then we attach an interrupt to the tachometer pin. This means every time the fan sends a pulse signal, the function onTach will run automatically and increase our tach count. This helps us calculate RPM accurately. Next, we start serial communication at 115,200 baud for debugging, and then start Bluetooth communication at 9,600 baud, which is the default for HC05. We print a few startup messages like Smart Fan Ready and tell the user what commands they can send, on, off, speed, or status. Finally, we make sure the fan starts off by writing 0 to the PWM pin. The void loop function keeps running again and again. This is where our program listens for Bluetooth commands and handles fan control. First, we check if the Bluetooth module has sent any data. If yes, we read the full command as a string and pass it to a custom function called handle command. Then, we do the same for the serial monitor, so you can control the fan from your computer too, not just Bluetooth. Every second, the program calculates the fan's RPM using how many tach pulses were counted. It multiplies the number of pulses by 30 since usually 2 pulses equal 1 rotation. Then it resets the counter for the next second and sends a status update that shows whether the fan is on the current PWM value and the calculated RPM. This status is sent both to the Bluetooth device and the serial monitor. Handle command. This is where the real logic happens. When a command comes in, like on, off, speed 200, or status, this function checks what the user wants and reacts accordingly. If the command is on, it turns the fan on and writes the current PWM value to the control pin. Off, it turns the fan off by writing 0 to the PWM pin. Speed, it reads the number after speed and adjusts the PWM output to control speed. Status, it immediately sends the latest fan data, on-off speed and live RPM. If the command isn't recognized, it sends back an error message telling the user the correct format. The send both function. This is a helper function that just sends the same message to both the Bluetooth device and the serial monitor. That way, no matter how you're controlling the fan, by phone or PC, you'll always get the same feedback messages. The ON-TACH function. This function is called automatically whenever the tachometer pin detects a falling edge, basically every time the fan blade completes part of a rotation. Each pulse increases the tach count variable by 1. Later, this count is used to calculate the fan's RPM. This interrupt system ensures that the Arduino never misses a pulse, even when it's busy doing other tasks. Final summary. So overall, this Arduino project does 4 main things: receives commands from Bluetooth or serial monitor, controls the fan speed and power using PWM, measures the fan speed in real time using the tachometer, reports everything back through Bluetooth or serial. It's a great example of combining hardware control, real-time data, and wireless communication, all in one clean, well-structured Arduino code. Now let's test our project. You can see the Arduino is running perfectly. All the connections are working as expected, and the code is functioning smoothly. If everything looks good, congratulations. Your project is complete. Thank you so much for watching this full video till the end. If you learned something new, please don't forget to like, share, and subscribe to Code with AHMAD. Your support means a lot and helps me make more awesome Arduino and programming projects. See you in the next video. Until then, take care.
طلع البدر علينا من ثنيات الوداع وجب الشكر علينا ما دعا لله دا ما دعا لله